So the odds of getting two heads when you flip a coin 4 times. Hey, while I'm talking, you're quiet. When you're flipping a coin 4 times, you have 2 to the 4th ways total that outcomes. 16 total outcomes. So if you want the odds of getting 2 heads, how many ways are there to have to arrange 2 heads and 2 tails? So the 2 heads could be 1st and 2nd, 1st and 3rd, or 1st and 4th. They could be 2nd and 3rd, 2nd and 4th, or they could be 3rd and 4th. So there's 6 different ways. 6 out of 16, but we want the odds, so that's a ratio of 6 to 10, which would reduce to 3 to 5. Usually. What are the odds of getting no heads when you flip a coin 3 times? No heads. And if you're looking at the odds, that would be 1 way. But how many total ways for 3 coins? 8. So then it'd be 1 to 7. Because you want them to add up to the total number of ways.
So 8 is how many possible ways?
Yes. And this is the total, 16 of total possible ways here. Here? No, it'll be 2 to the 3rd. Because there's heads, tails, heads, tails, heads, tails. Odds of getting only 1 head when you flip a coin 3 times. So again, we have a total of 8. But that 1 head could occur, right, 1st, 2nd, or 3rd position. So it'll be 3 to 4. No, I'm sorry, you're right, 5. So a total of 8. Three heads in a row on the first try would be the same as getting no heads in a row, 1 to 7. Probability of drawing, so we're back to probability of drawing 2 cards and getting both hearts from a standard deck of 52. The odds of getting a heart the first time around is 13 out of 52, which is 1/4. And the probability of getting a heart the second time around, though, changes because now you only have 12 hearts and 51 cards. So when you multiply that together, the 4 and the 12 reduce to 1 and 3. So you get 3 over 51, which is a decimal of about 0.6. 6.06, 6%. Odds of drawing a card and getting an ace. How many aces are there?
4. 2, 3, 4.
4. And how many non-aces are there?
It's 48.
How many total cards are there? How many total cards are there? 52. So 4 of them are aces, the rest of them aren't. So odds is aces to non-aces, which would reduce to that. If the odds in favor of the horse, the odds is usually written with a semicolon in there. Most of the time. Or with the word two, T-O. If the odds in favor of the horse Black Beauty winning the race are 2 to 5, what's the probability that they'll win the race? Right. So this is win to lose. So that means there's a total of 7. So when you're doing probability, you want to do win divided by total. not that as a percent, leave it as a fraction. So this added up to 7. That's total ways. 2 wins and 5
There's
lose.
7 total rounds, and then there's only 2 ways.
Consider a game in which fair coins are tossed. Payoffs are as follows: both heads is 5, both tails is 3, one of each is a loss of 1. So the probability of the heads is 1/4. So you win $5 1/4 of the time. You lose $3 when it's both tails, which is another 1/4 of the time. And a one of each occurs half the time, and you'll lose $1 half the time. So that will tell you the average amount per play that you will either lose or win if you play over a long period of time. It's a positive 1.
I think so. I'm going to check. He's checking.
If it comes out to 0, that means if you play over and over and over and over, you'll likely just break even over a long period of time. You're not really making a lot of money. But if you get lucky and you win 5, if you get both heads a couple of times, then once you get ahead, if you keep playing, you'll likely just lose it. All right, you have 1 pair of fair die. Find each of the following. What's the odds of rolling a 7? So if you have a pair of fair die, there are 36 ways that those 2 die could land. Yes. And each of those 36 ways is equally likely. 6 of those ways can equal a 7. You can have the 6-1 and the 1-6, the 2-5 and the 5-2, and the 3-4 and the 4-3. So you got 6 of those 36 ways will give you a 7. Okay? So 6 out of 36 is the probability, but the odds would be 6 to 30, 6 that are 7s and 30 that are not, which reduces probability of rolling a double. How many doubles are there? We can either get a 3, a 5, a 7, a 9, or an 11. Those are the only ways that we can get an odd number. There are 2 ways to get a 3. There are 4 ways that we can get a 5. 2, 3, 3, 2, 1, 4, 4, 1. There are 6 ways we can get a 7. And then we're back to 4 ways to get a 9. 6, 3, and 3, 6. 5, 4, and 4, 5.
And 2 ways to get an 11.
Correct. Only 2 ways to get an 11. 5, 6, and 6, 5. That's it. So that's the total of 18 out of the 36 total. The odds would be 1 to 1. 18 to 36 probability converts to 18 to 18 odds, which is 1 to 1.
13 million.
So this is a combination from 52, choose 5, and that's that number that we see all the time.
Where's this one?
Basketball team has 20 players on the roster. There are 5 positions. Point guard, left wing, left post, right post. How many possibilities are there? Well, this would be correct. That would be a permutation. So out of 20, we need a permutation to choose 5. So you do the same thing as before. Go to, So you get 20 math over to num, over to probability, have the, yep, and 5, 186.
It's actually a 9. So I'm just kidding.
0480.
Dude, migration
How many different ways can the words in the words, letters in the word Samsung be arranged? If they were all different, it would be 7 factorial. Since we have 2 S's, divided by 2 factorial, which is just basically 2. How do you factorial? 7. 7.
So there's 7 letters percent,
Math.
which makes 7
Probability. 4. Divided by 2. Because we have 2 S's. During a 5-year period, the methylchloroform man-made material went from 150 down to 120. What percent did the level decrease? So the original was 120. Oh, sorry, the original was 150. So we want the new minus the old over the old, which is a decrease of 30 from the original 150, which reduces to negative 1/5, which is negative 0.20, which is a decrease 20%. Yeah. From that to that is decimal form of percent, you times 500. 20%. You can either write it as negative 20% or say 20% decrease. Okay, you place $1,000 in investment, 10% compounded annually. How much will it be worth at the end of 2011? Well, at the end of 2008, we put it in the beginning of 2008. At the end of 2008, we'll have $1,100 because we have to add 10%. So 1.1 times 11 times 1,000 is $1,100. So each time we're going to multiply by 1.1, which means it's going to grow 110%. Because that's 110%. 1.1 is 110%. Move the decimal over twice. At the end of 2009, we started with 1,100 times 1.1. How much is that? Should be that. Calculate it. It'll show you. By the end of 2010, it's going to give us 10% of interest on top of that 1,210, which is what? What? And I have $1,331, and then by the end of 2011, which is what they asked, times 1.1.
It's 1464.1.
That's how much you should have at the end of 2011. All right, in 2011, enrollment was 18,200, that's an increase of 4% over the fall of 2010. What was the fall of 2010 enrollment? That was the old. The formula is new minus old over old. That gives you the percent change. So in this case, we don't know the old, we know the new. 1,000 or 18,200 minus the old over the old equals 4%. So I need to figure out what amount the old value would have to be to give me a 4% increase. So I'm going to multiply both sides by x. That'll cancel these two out. Then I'm going to add x.
You're gonna add keyboard.
Add x to both sides.
I know exactly how to play.
That's going to cancel this out. So I basically over here have 1 plus 0.04. So 1.04x. So 104% of what I had originally should be 18,200. So if I want to find out what that original value is, I divide by 1.04. That gives me the original value. I need 104% of 18,200. 17,500. Sorry, 1.04% of that is 18,200. That's the enrollment back then. That would give me a 4% increase. So 60% of my money is going to grow at that rate. 15% of my money is going to grow at that rate. Another 15 is going to grow at that rate. And 10% is going to grow at that rate. So I want to find the average rate of growth for my money if this is how it's distributed. So I go through and I say, okay, 0.6, which is 60, will grow at 11%. So my answer is going to be the percent growth. 15% of my money, 0.15, is going to grow at 8%. Another 15% of my money is going to grow at 14%. And the last 10% of my money will grow at 8%. So my money grows on average, if it holds to what it's been doing, 10.7% a year. 20% of the women take a test, and if 20% of the women are actually pregnant, 97% accurate, what's the probability that a positive pregnancy test result is accurate? So if we pretend like there's 1,000 to start with, and then that means that 200 of them were pregnant, and the other 800 were not. Then they took the test. It was 97% accurate. So that means out of this 800, 3% came back and said that they were pregnant. So 3% of 800 is 24 women. So 24 women were not pregnant. The test said they were. The other 776 were not pregnant and said they weren't. Then these 200 that were pregnant, 6 of them, which is 3%, said they weren't. Let's go over here, put them over here. 6% said they weren't, and 194 accurately said, yes, you're pregnant. So what's the probability that a positive pregnancy test is accurate? Okay? These were positive, these came back positive, and these came back positive. So a total of 218 out of those 1,000 women ended up with a positive pregnancy test. Out of that 218, 194 of them were accurate. So what percent is that?
Wow.
30.
88%? 88% accurate.
89 if you round it.
Oh, well, let's round correctly, please. Hello, Anthony. All right, so cell phone company offers choices for their phone. You can get the 4-inch or the 5-inch screen. That's 2 choices. You can get white, gold, and black. 3 choices for that. You can get the 64, 128, or 256 gig. That's 3 choices for that. And you can either use AT&T, Verizon, T-Mobile, or Sprint. That's 4 choices. So how many different combinations are there for the phone you choose? 6 times 12, 72 choices, combinations. How many ways can the letters tightly be arranged into a 4-letter string? If letters cannot be repeated, then it would be 4 factorial. If they can be repeated, sorry. 4 factorial is if they not. If they can, then it's 4 to the 4th. Which is what? And 4 factorial is 24. This is all women. If one woman is chosen at random, what is the probability that the woman is at least 65? There's a total of 21,784 women that are 65 and older. Yes. Now I know you'll get at least one right. See? We're on a roll. Now, can you get in the calculator right? Tell me the percent.
Yes, you still do it right. Did I do it?
Yes.
Really, my calculator wasn't on that whole time I was talking.
10th place, that 4 would change to a 5. Let's go ahead and do that. 18.5%.
It's gonna be 18.5%.
What's the conditional probability that the selected woman never married, given that she is at least 65? So that means that we're assuming she never gets married in the future. As of right now, probability that the selected woman was never married. Why is this not moving? Never married. Never married is a total of that, right? At least 65 would be that. So we're looking at 984 divided by 27,792 is what probability?
Yes. No. Yes?
Or decimal. So 0.04 probability. Never married and at least 65. So they have to be both never married and at least 65. That's just going to be this number right there, 984.
I think it's still just on total number of married. Yeah. I think it's all of it.
It's that over that. So there was 984, which came out to what percent? You divide it by 1,180,000.18%. 0.8%.
Divided it,
0.008
times 100.
If one woman is, we'll skip that one. If one woman is chosen at random, what is the conditional probability that she is 18 to 29 if she's divorced? 18 to 29.
Divided by 13. I win.
Yes, sorry. 612 over 13,749. What was A? What was 24A's probability? What's the probability she is divorced? Given she's 18 to 29, she used, what was it?